Well, what do we got here? Bunch of junk. Probably 5-6 years ago, a friend of mine was cleaning out his barn, and he had these old radios, and there wasn't much left of them. And he decided to give them to me. He was just going to throw them away, and I thought maybe there'd be some parts in there. There wasn't much. They're in pretty deplorable condition. That tuning cap is froze up. You know, there's not a lot there. But I pulled the IF cans off of them. This one I pulled the speaker off. It's in this box. Pulled the transformers off of them. This one didn't have a power transformer. This is an old Chevrolet car radio. There wasn't much in there worth saving. But I do have some parts. This one here, I think, is actually a Zenith, and I got the Bakelite cabinet that it was in, but it's in really rough shape. And it's funny, it's got push buttons here, and that whole mechanism is missing. I don't know where it is, but I do have the front plate, which is in really bad shape. It does say Zenith on it. And I thought this would be good practice for trying to polish Bakelite, you know, sand it and see how that comes out, because it doesn't, I mean, it's ruined. That's cracked there. It's missing a whole piece, broke out of it over here. You know, so it's not worth anything. You know, it's not even really fixable. But I could practice and play with it and see about, you know, sanding on the Bakelite and see how that comes out, polishing on it. Anyway, and this, I believe, is the chassis that came in here, because it's got this rounded edge. And let's set this down here. This is just some of the parts that I got. I got a bunch of these coils, or IF cans here. None of them tested open, surprisingly. Some of them are in pretty bad shape. But there was no shorts and there was no opens. I also got this little coil, 12 ohm, 6 ohm, 12 ohm. I don't know what that's for, but I got the faceplate there. This tuning cap is in reasonable condition. It still turns, though it's rusty. This is the tuning system out of the Chevrolet car radio. I haven't pulled that apart yet. Got a whole bag full of resistors, most of which are out of tolerance, but I thought if you ever needed one for replacement, you could put it in as what it measures. I do have the push button assembly out of the car radio. I'm surprised the plastic's not all disintegrated. It's actually in really good shape. And there was a little polished aluminum plate. I kept that and thought this was kind of neat. The tuning thing says Chevrolet on it. Probably end up throwing most of it away. I don't know. There's one of these bar resistors. It's open between here, but I'm not sure if it's supposed to be. This section measures 30 ohms, and then these are all connected together. I'm thinking there's supposed to be resistance there. It's not supposed to be open. And I did get a little output transformer, 570 on the primary and 2.5 on the output, or 2 on the secondary. And I got a couple power transformers. I was hoping they would be good. They all ohm out good. They ohm that there's no shorts and no opens, but there's resistance to the case, and I suspect that's because they got moisture in there and it swelled up and maybe corroded some of the windings. So they're not actually broken, but they're probably no good. As soon as you put 110 volts to them, they'll probably self-destruct. Both of them have resistance to the case. They just sat around too long out in the weather. But oh, and I got the this too. This is the input jack from the car radio, and it's got a really fat coaxial type cable on it. I thought that was kind of neat. But anyway, this all started out as a project for something that I want to build, and I need an IF coil. So I thought, well, I'll go look for one of them. So then of course I had to strip all these radios, get all the parts off them. Of course I needed a couple tubes, so that prompted me to get all my tubes out and sort through them all and organize them all and test them all and label them in the boxes. And of course that took longer than I suspected it was gonna. Even got this Vidicon tube. It always takes longer than I thought. So with that said, I don't think we're going to work on that project first. I have a couple other things I want to strip down for parts, and I'll show you those next. First up is this monster. This is a arc lamp power supply from a new arc plate maker that I got from where I work. I tried to sell it. Nobody wanted to buy it. It's got taps for different voltages, and the voltmeter is missing. I actually stole it and put it in the Variac project when I built that. But the idea was, you look at the voltage on the meter, and whatever it said, you'd set this to the closest voltage. It's 220 volts, 17 amps draw. I'm not sure what it puts out for the output. There's a separate little power supply that is the starting power supply. It gives it an arc. It's built like an ignition coil and a little vibrator, but that's not on this board. That was a separate mounted thing, and it's out in the barn yet. But there's a massive big power transformer here with all the taps for the primary, and then the secondary goes to this capacitor, and then through that, which I'm assuming is what they call a reactor, or I think it's just basically an inductor, and then comes out of the inductor to this capacitor, and then this is your lead that would go to the high voltage between these two leads here. This did work. The bulb was iffy. Actually the one end of it had broken off, but it was still making contact, and I did get it to light once and then as soon as it heated up, it went out, and there's no real way to fix the bulb, and they're like $300, so I'm not going to buy a bulb just to play with it, but I'm going to strip it down, take the parts off of it, see what I can maybe do with this big transformer. I have to suspect it's got quite a bit of output, but I don't know what the voltage would be, and I don't know if I can read it on those caps. They're pretty rusty, but we'll see. And I do have the control panel down here, a couple toggle switches and stuff I've taken out of it, but there's a good vacuum gauge and a bleeder, a little timer, pilot light, one more switch over here, a couple fuse holders on the end. We'll take that out, and I do have the matching socket for that somewheres. So I'm going to strip this down to its essentials, and yeah, we'll go from there. Alright, I got a bunch of parts. Here's all the hardware, bolts and spacer washers and stuff. This is an inductor. It measures about 1/2 ohm. Of course, I got my two big caps. One's got a shorting resistor on it. Got plug socket. This little relay. Contactor for 25 amps. It's a nice little contactor. 208 to 230 volt coil. A couple pieces of high voltage wire, about 2 foot long each. And of course the big boy. I still got it attached to the control. And these are what I've measured. I measured 1/2 ohm on the primary, and the secondary is about 1 ohm. And the red wire should be center tap. So that's this red wire here. Should be a center tap, which would give you 120 volt output. It's about 2.5 to 1 turns ratio. By my calculations, I didn't run it on 220, but if I put 50 volts in, I get 130 out. And if I put 100 volts in, I get 250 out. So it should be about 2.5 to 1, which means if you feed it with 220, you should get about 550 out on the secondary. And it was labeled as a 2,000 watt supply, continuous, which means it'll put out 3.6 amps at 550 volts continuous, but I suspect that the surge is quite a bit more, because this is quite a beefy transformer. So anyway, on to the control panel. Not a lot of stuff, but I found the other plug. Goes to that socket. I got a power switch, double pole, single throw, safety limit switch was on the door, normally open, a 2-position terminal block, a little vacuum bleeder. Basically it just opens this vacuum port to atmosphere. Let me thread this open. Simple. Pilot light. One fuse holder. The other one was cracked, and it kind of fell apart when I took it out, but I did save the fuse out of it. 30 inches vacuum gauge with a pair of pants fitting, and a little, I think it's a 5-minute timer, an electromechanical 5-minute timer. Turn it past 1, and then set the time. Little motor on it, kind of nice. So that's it for that. We got this ancient old microwave to tear apart. I've already ripped the outside cover off because I want to make sure there was no mice or anything in there that would come out in my house. Because my shop is in my house in the winter. This thing is old and smashed and dirty, but that's what I want. The MOT. There's a couple other things in here, you know, like the fuse holder. Probably pull the magnetron out of it. Capacitor, there's a diode. You know, various switches. Little electronic food temperature control. This is frozen up. It's all frozen up. It's got a timer. Somebody broke the knob off the timer before I got it. And I actually got it from work. It's a little bit frozen and nasty. It's been sitting outdoors for 3 or 4 years. And there's a little stirrer motor. Door switch. So anyway, I'm going to tear some parts out of this. And the microwave is disassembled. Here's the microwave oven transformer. I'm going to check that, make sure that's good. A little cooling fan that spins. And of course, there's the magnetron. It's Panasonic 2M167. I don't know what that means. Oh, here's the capacitor. 850 microfarads, 2500 volts AC. And the diode. There's a couple other, you know, the door switch, the fuse holder. There was this 5 ohm resistor, and there was this big massive resistor with a tap on it. And I'm gonna guess that this was for the temperature, because it has a switch, low, medium, and high. It's kind of froze up. Probably no good. Probably end up throwing that out. It's a bulb and socket. The stirrer motor and stirrer. That was the start button. No mechanical timer, even though the buttons broke off. I might be able to fix that up. It's kind of neat. It's got a bell on it. And pilot light. And got the temperature control. It had a probe. I didn't get the probe. But you just turn this dial. And that turns up and down that potentiometer that was hooked to this little circuit board, the ECU. So yeah, anyway, a bunch more stuff. I'm going to test out that transformer now. Alrighty, I've tested out the microwave oven transformer, and I got some information here. I put 50 volts on the primary, and across these two bottom leads, which is the filament, I got 1.4 volts. So that means with 120 in, should get about 3.36 volts out the filament. I also tested the high voltage leads, which are here. There are 2, and it would appear that the center tap is grounded, but it's wired kind of weird. If I measure between these two, with 50 volts in on the primary, I only get 28 volts across here. But if I measure between either one of these and ground, from this one to ground I get 875 volts, and from this one to ground I get 900 volts. So it's almost like if you were to put these together, you would get about 875 or 900 volts at twice as much current. But I'm not positive. It's almost like they're in the same phase, because it's about 25 volts difference, and that's about what I got. I got about 28 volts difference between them. So it's almost like they're the same, they're wound the same way on the transformer. So it's not a true center tap, it's like two completely separate windings. There was some paperwork with the microwave. I got to go out to the junk pile and grab that. I think it had a schematic in it. Maybe it'll show the transformer. I don't know what we can do with this bad boy, but I have some ideas. Anybody who might think they want to play with one of these, just be careful. If you don't know what you're doing, don't mess with it. They are very high voltage and considerable amount of current, at least an amp or two coming out of the high voltage. So 2000 volts at an amp or two will definitely kill you. And being that the center tap is grounded, and that's where the high voltage is between ground and one of these terminals or the other one. If this transformer is actually grounded, and you're grounded, like touching the ground, and you accidentally touch one of these, you're dead. So 2000 volts is more than enough voltage to bridge the resistance in your body, and an amp or two is way more than enough if it goes across your heart to kill you. So with that safety note out of the way, I think I'm going to go see about finding that paperwork. Of course, it's dark outside now. I probably shouldn't have thrown the thing away. But anyway, I'm going to grab that paperwork and see if it explains about how the internal making of the transformer is, and then maybe we'll play with a couple of these other things here. Well, it does include a schematic and a wiring diagram, although it's kind of moldy and damp from being outdoors for 2 or 3 years. It was inside the unit in this little envelope. Important: do not remove envelope or destroy contents. Replace contents in envelope. And the paper that's in there is just about safety brackets and mounting it to the wall and blah 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 and all that crap, and how microwaves work. But the most interesting part I wanted to see was this part right here. It shows the power transformer, shows the ohm readings, 1/4 ohm on the primary, 70 on the secondary, 1/10 of an ohm on the filament. That big resistor right here is in fact how they get the different power levels on the microwave, which is kind of an oxymoron. You're wasting a bunch of the power in a resistor. But it shows the high voltage winding. It's not the center tap that's grounded, it's actually one end of the winding. I don't know how well the camera's probably not going to pick that up. It's probably not going to focus. But one end of the winding is grounded right here, and the other end, terminal 7, is the highest end. Terminal 6 is just back a little bit, and apparently terminal 6 wasn't used. So actually hooking 6 to 7 would be bad, because it would just it would actually lower the output of the transformer, because you'd be shorting out the last little bit of that winding. But anyway, so yeah, so it looks like from 7, it says right there, high voltage, high is 7, low is 6. If I'd have read that, I probably would have known. Alrighty, we've got the timer all cleaned up and lubricated. I don't know what I'll use it for, but it's kind of neat. It's old retro looking mechanical timer. I had to take it all apart. The gears in here that click over from seconds to minutes and minutes to 10 minutes, those were froze up on the shaft, and the number wheels were really stiff. They didn't want to turn. But it hangs up every once in a while when it goes from 1 minute and clicks back to 55 seconds and goes on down. It'll hang up a little bit and slow down, but the motor might be a little bit weak, but it does run. Pizza's ready. The ding is the coolest part. It's like a typewriter going off. It's got this little bell on the back, and there's just a little hammer in there that trips it when it hits 0. So that's kind of neat. I'm going to see if the stirrer motor will work. Alright, we've got her hooked up. And nothing's touching. So let's turn around and see what happens. Oh yeah, it runs. Look at her go. I think it's like 120 or 140 revolutions a minute. There's like absolutely no airflow coming off of it because it's not really a fan. But it does run. Don't know what I'll use that for. Maybe a cool retro windmill project. If you had a miniature windmill that could run it with electric. That's a good idea actually. But I don't have one. So I guess that's all the testing we got to do today. I almost forgot this baby. Let's see if she runs. Oh yeah. Yep, she runs. I don't know what we can do with that microwave oven transformer, but we ought to have some fun with that, especially when the weather gets nice and we can get outdoors. So, anyway, I guess that's it for tonight. I guess, just if you're going to, again, play with a microwave oven transformer, be very careful, because they will kill you. So on that note, thanks for watching and looking at some of this junk that I got. And tune in next time.